Hello everyone. Today we are diving into object-oriented databases. In this session, we'll look at why complex data types have become so important, how the object-oriented model works, and how languages like C++ and Java support persistent databases. By the end of this lecture, you'll understand how object-oriented principles are applied in database systems and how they're different from the traditional relational model. In early database systems, we mainly dealt with simple data types, things like integers, strings, and maybe some dates. But today's applications need to handle much more complex structures, multimedia, CAD files, documents, and hierarchical data. Take addresses, for example. Instead of splitting an address into street, city, and zip, which makes querying harder, it's sometimes more convenient to treat it as a single complex object. This is where object-oriented databases come in. They're perfect for domains like software engineering, design, and even multimedia. Now, let's talk about the object-oriented data model. This model borrows concepts from object-oriented programming. Think of an object like an entity in the ER model, but with behavior. It encapsulates both data and methods that operate on the data. This encapsulation is the key strength. Everything related to the object is bundled together. Each object has three components: variables, these store the data. Messages, these are like functions or requests sent to the object. Methods, the actual code executed in response to messages. Here, only the object's interface is visible, the internal details are hidden. This is abstraction, which is a core principle in OOP. Methods in object-oriented databases are similar to those in programming. They manipulate the object's own variables and interact with others via message passing. Each attribute must have methods to get and set its value. For example, we use getAddress and setAddress for an address field. This provides controlled access to data, very different from the free access in relational databases. Similar objects are grouped into classes. Just like entity sets in the ER model, a class defines the blueprint, the variables, message interface, and methods. All instances of the class follow this blueprint. An example, we could have a person class and group all individual person objects under it. Here's what a class looks like in code. This is an employee class with variables like name, address, and salary, and methods like getName and employment length. Notice how methods like setAddress are written to modify object data. This is encapsulation in action. Data access is managed through defined interfaces.